So next I want to talk about what's called the inclusion-exclusion principle, and this is going to tell us how to find the cardinality of a union of three or more sets. So this is going to generalize what we had before for the sum rule for counting. And what this is going to say is that when you have three or more sets, the way that you find the cardinality of the union of those sets is you first add up the individual sets' cardinality. So you add up, if we would have three sets, we would have cardinality of A plus B plus C. And then you subtract pairs of intersections. So you'd have A intersect B, A intersect C, and B intersect C. And then you'd add triples, and then you'd subtract quadruples if you had any, and add, five sets taking the intersection together all the way until you're done. Okay, and you keep alternating this. So in general, the way that this works is that if you have the cardinality of A1 union up to AN, you're going to add the individual sets, you're going to subtract pairs of intersections, add triples of intersections, subtract quadruples of intersections, and so on until you get to this one final term here. Okay, so this is called the inclusion-exclusion principle because you're adding the odd numbers of intersection sets and then subtracting the even numbers of intersection sets. So for example, if I wanted to count the number of positive integers less than or equal to 1,000 that are multiples of 3, 4, or 5, we're going to use the same notation that we had before. I'm going to let a sub n be the number of positive integers x such that x is less than or equal to 1,000 and x is a multiple of n. Okay, so that's what I'm going to use for our notation a sub n. And we want to count, our job is to count A3 union A4 union A5, right? We want to find the number of integers that are multiples of 3, 4, or 5. And this is classic inclusion-exclusion. So what we can do is we can add the individual cardinalities, A3 plus A4 plus A5. We're going to subtract pairs. So we're going to subtract A3 intersect A4, A3 intersect A5, and we're going to subtract A3 intersect, A4 intersect A5. So let me write that a little better, A4 intersect A5. And then we're going to add to that, I'm just out of room, but we're going to add to that the intersection of all three. A3 intersect A4 intersect A5. Okay, and so now what we need to do is we need to think about what are these sets. And of course, when we take intersections, we're talking about ands. So for the first set, this is just, I'm just going to call it A3, A4, and A5. So A3, A4, and A5. The second set, to be a multiple of 3 and 4 means that you're a multiple of 12, because that's the least common multiple. So that's A12. To be a multiple of 3 and 5 means that you're a multiple of 15. To be a multiple of 4 and 5 means that you're a multiple of 20. And to be a multiple of 3, 4, and 5 means that you're a multiple of 60. Okay, and so we can add all these up. This is going to be the floor of 1,000 over 3 plus the floor of 1,000 over 4 plus the floor of 1,000 over 5 minus the floor of 1,000 over 1,000 over 12, excuse me, minus the floor of 1,000 over 15 minus the floor of 1,000 over 20 plus the floor of 1,000 over 60. Okay, and so you could add all these up. I'll leave that to you to add up and figure out exactly what you get, but that's how this would work. That's how inclusion-exclusion works. I'm going to do a similar exercise here. How many positive integers less than or equal to 1,000 are multiples of 4, 5, or 6? Here, using the same notation as above, we're going to find the union, the cardinality of the union, A4 union A5 union A6. That's going to be the sum of the cardinalities of the sets, A4, A5, and A6. And then we're going to subtract pairs of intersections, add triples of intersections, and that's where we'll have to stop. So now we're going to subtract A4 intersect A5. So I want to write this out just to be clear. Minus A4 intersect A6, minus A5 intersect A6, and then finally plus, we're still out of room, A4 intersect A5 intersect A6. Okay, and so this is going to be, there's not much to do about the first parts. These are just what they are, A4, A5, and A6. Now A4 intersect A5 is going to be A20, because the least common multiple of 4 and 5 is 20. A4 intersect A6 is going to be a 12, because the least common multiple of 4 and 6 is 12. And A5 intersect A6 is a 30. And then finally, we'll add to it the intersection of A4, A5, and A6. That's going to be, let's see, I think the easiest way to do this is to look at A4 and A6. Their least common multiple is 12, and then the least common multiple of 12 and 5 is 60. So this will still be A60. Okay, and so you could basically mimic what we did above, take the floor of each of these, floor of 1,000 over 4, floor of 1,000 over 5, floor of 1,000 over 6, minus the floor of 1,000 over 20, minus the floor of 1,000 over 12, minus the floor of 1,000 over 30, and then plus the floor of 1,000 over 60. And then again, I'll leave it to you to actually calculate what these numbers actually are. Okay, but this is inclusion, exclusion at work.